Hey, welcome back. Today we move into the second half of Module 1 about the product metrics. This is the lecture that completes the analytical cycle we've been building. Last time, you learned how to frame a problem and dig into its root causes. Today, you'll learn how to decide what to measure so you can actually tell whether your work matters. And so you can spot the next problem before it gets big. This lecture is heavy on frameworks and work examples. 3 of the slides are full case studies from Facebook events, a friend request investigations, and a fractional metrics scenario. By the end, you'll have the working vocabulary of product analytics and a few habits that separate strong analysts from sloppy ones. Let's start by connecting back to where we left off last time. Quick recap. Last lecture we built 2 related skills: problem framing, the discipline of defining and understanding a problem before solving it, using the established, justify, contextualize, write canvas, and root cause analysis, the discipline of tracing a problem to its underlying source. Using tools like 5 whys, the fishbone diagram, Pareto, and FMEA. Now, here's the question that exposes the gap. Imagine you actually went through the whole process. You frame a problem, you did a fishbone, you identify what you believe is the root cause. You implemented a fix. How do you know it worked? And just as important, how would you have caught the problem a week earlier, before it became a problem worth doing on this work on? Both answers live in metrics. That's where today's lecture begins. Problem framing tells you what to solve. Root cause analysis tells you why it happened. Metrics tell you whether you fixed it and what to watch so you catch the next one early. Those 3 together are the analytical loop. So let's start at the beginning. What is the metrics? So what is a product metrics? So strips away the buzzwords, and a product metric is just a number that tracks something we care about: user behavior, business outcomes, engagement, growth, revenue, satisfaction. The reason metrics matter is captured well in the Drucker quote at the bottom. What gets measured gets managed. The deeper point, and the one I want you to take away, is the flip side. If you don't measure something, you can't tell if your work is helping, hurting, or doing nothing at all. Without metrics, every decision becomes a debate about whose intuition wins. Metrics turn opinions into evidence. They let teams agree on reality. That's the whole game. But before we get into how to pick good metrics, we need to talk about the mindset that makes good metrics work possible. And that's the product sense I'm talking in the next slide. Product sense is one of those terms you hear constantly in tech, but rarely see defined clearly. Here's my working definition. It's the habit of understanding the product, the user, and the business before you reach for the data. It's how analysts move from being people who write correct SQL to people who produce insights that actually change decisions. 3 habits will build it for you. 1. Actually use the product. This sounds obvious, right? It is the easiest one to skip and the highest leverage. You cannot reason about a product you never use as a real user. 2. For any product or feature, ask, what is this team trying to do? Every product exists for a reason. Before you measure anything, get clear on the goal for the company, the team, the feature, the user, etc. 3. Connect every metric back to the company's mission. If you can't trace a number to why the company exists, the number probably isn't worth tracking. Notice, project sense is the metric size equivalence of problem framing. You can't frame the right problem without understanding the context, and you can't pick the right metrics without understanding the product. Same skills, just different deliverable. What makes a good metric? There are 3 tests every useful metric should pass. 1. Actionable. If the number moves, would your team actually do anything differently? If the answer is no, it's decoration. Cumulative sign-ups is the classic failure. It can only go up, so it makes leadership feel good but doesn't help any team decide what to do next. Secondly, relevant. Does it connect to a real business or user goal? Tie back to the mission, not to what's easy to track. Thirdly, measurable. Can you actually capture it with the data you have reliably and frequently enough to act on changes? Customer happiness is the most important thing in the world, but hard to measure without instrumentation. So we use proxies. The blue term at the bottom is the test I want you to internalize. If you can't say what decisions this metric would change, it's probably the wrong metric. Use that line every time you pick a metric. It will save you from 1,000 bad ones. Now, even with these 3 tests, there are organizing structures that make picking and grouping metrics much easier. The most famous one is up next. This is the Paris Metrics Framework, R, from Dave McHugh in the late 2000s. It's still the cleanest taxonomy for product metrics, and it maps the whole user life cycle. First, you acquire a user. They discover the product. You activate them, which is they hit the first key moment, the aha moment, that makes them realize the product is valuable. Then you retain them, and they come back, and you generate revenue. And ideally, they refer others, bringing more people in. Almost every product metrics you encounter fits in one of these 5 buckets. The bonus note at the bottom is important. Engagement isn't formally in R, but I treat it as a clue. For example, like DAU, daily active user, or monthly active user, MAU, session per user, action per users. Those are engagement metrics that sit between activation and retention. When you join any team, one of the first questions to ask is, what are our key metrics at each stage of this funnel? If they can't tell you, the team probably doesn't have a clear measurement strategy. R maps the whole funnel, but high-performing teams usually have one metric they rally around above all the others. That's our next slide. The North Star matrix is a relatively new concept. It became popular in the 2010s, especially with broad-state tech companies. The core insight: if your team is staring at 50 different metrics, no one knows what to prioritize. So pick the one number that if it rolls, means the product is actually working. Look at the examples, like here Airbnb. The North Star metric is the nice books. Why? Because that's when a guest stays somewhere and a host earns money. Value on both sides. For Spotify, time spent listening, not sign up. Because someone who signs up and never opens the app isn't getting value. Notice what not on this list, the revenue, right? None of these are revenue. Revenue follows value delivery. So good North Stars lead revenue. If you pick revenue as your North Star, you're optimized for short-term extraction. If you pick value delivery, revenue follows naturally. The warning in the call out is important. Avoid metrics that always grow regardless of whether you're winning. Cumulative sign-ups, total downloads, total likes, they make leadership feel good, but they don't actually measure success. We'll come back to that in the pitfalls slide. Okay, so now I would like to show you some common metrics by industry. So often students think that metrics doesn't mean tech company metrics, but every industry has its own metrics vocabulary tied to what actually drives that business. For example, in tech, the business is built on usage and stickiness. So you see like daily active user, monthly active user, retention curves, conversion rate, net promoter score, churn, etc. In finance, the units is dollar as risk and dollar earned. So you see the assets under management, net interest margin, return on equity, default rate, customer lifetime value. In healthcare, the units is patient outcome and safety, like readmission rate, mortality rate, patient satisfaction scores, wait time. In any data teams, the business is trust in the data itself. So you see freshness, pipeline, uptime, query latency percentile, model drip. So the pattern called out at the bottom is takeaway. So we use the same frameworks for metrics like R, the North Star, but each industry have different or specific metrics. So when you start a new job in any industry, learn the metrics vocabulary first. Ask yourself, what does this business sell? What does success look like to the people who pay us? Those questions point you straight at the right metrics. Okay, so we now know what good metrics look like and how they vary across industries. The next question is, where do we go wrong? Even with the best intentions, there are predictable traps. There are 4 common metrics pitfalls or 4 traps. The first one is vanity metrics, numbers that look impressive but don't drive any decisions, like total cumulative sign-ups on-way rows. Page views can rise from just bot traffic. They feel like success without proving anything. Here's the connection I want to make explicit, and this is important. Vanity metrics are exactly like the symptoms we discussed in root cause analysis. For example, like the fever problem. So a fever is the visible signal of a deeper problem. If we just take like the Tylenol to treat, and then the fever breaks, and then we declare victory, but this might still be like infection growing, right? And that's the root cause we missed. So vanity metrics just do the same thing. So a company hits 10 million sign-ups, the headlines rise itself, but 95% of those users never come back after day one. So here, the sign-up metrics went up without anything getting healthier. So it hit a serious problem instead of revealing it. Same strap, different domain. Second, Goodhart's law. It states when a measure becomes a target, it ceases to be a good measure. So this is one of the most important principles in all of analytics. So once you reward people for moving a matrix, they find shortcuts that move the matrix without moving the underlying goal. So for example, you reward call handle time, and then the agents will rush customers up the phone, which creates repeat calls. Or a company reward bird cows, and tester will split birds in two. So people usually games incentive. Third, proxy strips. A proxy is a stand-in for something you can't measure directly. Time on site is a proxy for engagement, but the proxy can drip. If users get stuck on a slow page, time on site goes up, and now you're measuring frustration, not engagement. 4. Ratio confusion. In any fractional matrix like x per y, always ask which side move. So there will be a slide dedicated to these issues. So defense across on 4. So we need to define metrics precisely, pair them with counter metrics, and revisit them as the product changes. The first defense distinguishes predictive signal from descriptive ones, and we're talking about it in the next slides. And this distinction shapes how dashboards are designed. So leading indicators predicts what's coming. So they fire before the outcome. Onboarding completions is a leading indicator for retentions. If it drops this week, retention will drop in 3 weeks unless you intervene. Free trial activations is a leading indicator for conversion. So number of friends added in week 1 is a leading indicator for long-term retention on social platform. Second indicator is lagging indicator. This one are the outcome itself. So quarterly revenue, annual churn, year-over-year growth, they're reliable, and they're useless for changing the outcome, because by the time they move, the decisions that drove them were made months ago. So when you're working on a dashboard, right? So a strong analyst dashboards track both of these. But your highest impact work is almost always around leading indicators. That's where there's still time to change the story. A way to remember it. Lagging metrics tell you how the story ended. Leading metrics give you a chance to rewrite it. Now, even when you pick good leading metrics, optimizing for them can backfire. That's where Guardrail metrics come in. This is the direct antidote to Goodhart's law from the other slide I mentioned. Guardrail metrics. They are an underappreciated concept that separate rigorous analysts from sloppy ones. The setup, so every optimization has trade-offs. The metrics you're trying to move isn't the only thing that matters. So take the example on the slide here. You have the primary metrics, right? Like checkout conversion rate. You want to improve it. So you remove the shipping cost review to reduce friction. So conversion goes up, look like win, but refund rate is low because people are surprised at the total. Support tickets per order also climb, net negative for the business, but a win on the dashboard. That's exactly the Goodhart problem from the previous pitfalls slide. So Guardrail's metrics are how to catch it. You define them upfront. This experiment wins only if my primary metrics improves and none of my guardrails degrade materially. Common guardrails like latency, error rate, customer support volume, downstream revenue churns. So when to use it? Anytime you ship an A/B test or feature launch, define your guardrails before you start. Without them, you occasionally celebrate wins that are quietly hurting the business. We now cover the what metrics look like, what to avoid. So the rest of the lecture is about the how to actually choose metrics for a product. And I'm gonna discuss them. The first framework is Goal Question Metrics, or GQM. So it's come from the software engineering originally. It's invented by the author named Basili, and he wrote it in 1992. But it's perfectly suited for product analytics. The discipline is to start with the goal and work down to the metrics. Most bad metrics come from the opposite path. So someone asks, what can we measure? And the answer is whatever's already instrumented in the system. That's how you end up tracking page view instead of something that matters. So GQM forces a different sequence. First, what do we want to know? Then, what question would tell us? Then, what metrics answer those questions? So look at the example flow. First, goal. Help users find events they want to attend. Questions that would tell you you're achieving it. Are users finding events? Do they actually attend? Do they come back next month? And metrics that answer those questions. Events, browse persistence, attendance rate, repeat attendance after 30 days. Notice every metric has a clear question behind it, and every question ladders up the goal. Each links in the chance is justified. Always start with the goals, always. There's a second framework that goes a bit deeper into product structure, and let me show you. Okay, this is the second framework for product metrics. So most teams don't formally call it goals, objects, flow metrics, but this is the actual mental motion strong analysts go through. And step 1, the goal, same as GQM. State what you're trying to achieve. Step 2, this is the underappreciated step, identifying the objects. Every product is fundamentally a collection of nouns and the relationship between them. Host, events, attendees, driver, rider, rides, buyer, seller, listing. Once you can name the objects, the metrics fall out naturally. Step 3, the flows. How do users move between objects? What are the funnel? What are the loops? Step 4, the metrics. Per object counts, per object engagement, conversions between objects. So the next slide is a work example of this exact framework on a real product. And we're going to work through the Facebook events together using on 4 steps. Okay, let's work through this together. We're measuring success of Facebook event. Step 1, goal. Facebook events helps users discover and attend events with people they care about. So our goal is to increase engagement and meaningful interactions on the platform via events. Step 2, objects. Hosts create events. Events are the team being attended. Attendees are SVP and show up is effectively a two-sided marketplace. Step 3, flows. Discover events. Through newsfeed, invite, or browse, and our SVP, attend, post photo and comments. then discover the next event. And there's also a viral loop, like a friend creates an event, the host friend get invited, friends attend, those friends engage with the host later. Step 4, metrics. So events created per active host. This matrix if for the question, is the host side healthy? Or we have the attendance rate, which is the attended divided by SVP. This is for the questions, do events actually happen? Repeat host rates. This is for the question, is it sticky for hosts? Average events attended per user per month. So here for the question like, is the attendee site healthy? Post and photo per event. So this matrix is for the question measures engagement during the event itself. So each matrix has a clear question behind it. Contrast with the bad matrix in the corner, like the average likes per post per event is measurable, but it doesn't tell us whether Facebook events is achieving its actual purpose. So now we have a clear pattern for choosing metrics. The next half of the lectures is about what you do when those metrics move, when something changes and you have to figure out why. This is where today's material starts to look a lot like last time materials on root cause analysis. So a matrix moves, now what? So this is the 4-step framework. It was a strong analyst used to investigate matrix changes. First, clarify. Define exactly what's moved, what's the matrix, what's the time frame, sudden drop or progressive decline, friends request, sent or accepted. The most common mistakes that students make is skipping this step and zooming straight to hypothesizing. Always pin down exactly what moved before you guess why. Context. Is the change isolated or part of the broader trend? Is the rest of the product also down? Did anything launch, break, or trend right before the change? Hypothesize. Generate multiple plausible explanations. This is where the MECE concept comes. I'm gonna explain it in the next slide. And then validate. Pick the segment most likely to discriminate between hypotheses. Visualize the data, confirm or rule each one out. I want to point out something important. This framework is the same motions as the 5Y from previous lectures, just a different tool. So 5Y ladders down from a symptom to a root cause through conversation. This framework does the same thing through data. So one is qualitative, one is quantitative. And as a strong analyst, they use both of these methods. Live work, remember. So 5Ys get you the hypothesis. Segmentation tells you which hypothesis is right. The common segmentations at the bottom are your toolkit. For almost any matrix change, cut in by user cohort, geography, device, channel, time, or product surface, reveals where the change is concentrated. The concentration usually is the answer. MECE comes from the Amendments Consulting and McKinsey's is famous for it. The idea is simple but powerful. When you break a problem into parts, make sure the parts first don't overlap, that's mutually exclusive. And second, they cover everything, that's collectively exhaustive. Together, they ensure that no course gets double counted and no course gets missed. Here's the thing, you've already been doing MECE without calling it that. Remember the fishbone diagram from last lecture, the branches, people, methods, machine, material, they are MECE categories. They don't overlap, and together they cover the major sources of variations in any process. And today we're just giving the concept a sharper name and apply it to the metric work. For product analytics, MECE shows up in two places. First, hypothesis generations. When investigating a metric drop, you want hypotheses that don't overlap and together cover all plausible causes. Second, segmentations. When you slice users by any dimension, the segment should be MECE so percentages add up and you don't double count. The tree on the slide here as work example is the friend request example. So the root questions split cleanly into internal versus external. That's the MECE split. Then each branch breaks into concrete causes. In a real investigation, you add more branches if needed to stay collectively exhaustive. The test is, could anything fall outside these buckets? If yes, add a branch. Okay, the next case study is about the friend request case. So the setup is, so at Facebook, friend request dropped 10% last month. Why? So now we apply the framework. In step 1, clarify, we look at sense or accepted, sudden drop or gradual. Use only a global, define exact metrics before guessing. Step 2, context. So here ask the question like, is total Facebook traffic also down 10% or just friend requests? Did any product launch in the same week? Step 3, hypothesize. Here we can segment by new versus existing user, geography, device, product service, profile per page versus people you may know versus mutual friends. Step 4, validate. So if the drop is concentrated in one segment, say new user on mobile in the US, you narrow the search dramatically. The right side shows 4 different hypotheses, and notice how different they are. New user influx fell, a demand side change, competing service 1, Facebook Marketplace button move next to friend request, stealing clicks, tracking bursts, like an event login gen block part of the funnel, so the drop is in the data, not the user behavior. Demographics shift, user base aging up, and older users send fewer friend requests on average. The lessons in the call now. Strong analysts generate many hypotheses, then let segmentation root them out. Don't anchor on the first explanation that pops into your head. If you only generate one hypothesis, you find evidence for it whether it's true or not. That's confirmation bias in action. So now we cover the absolute metrics like count, total, durations. So the last case study we cover ratio metrics, which are extremely common and extremely commonly misunderstood. Okay, so fractional metrics. So they are everywhere in products analytics. Applicants per job, posts per user, revenue per sessions per user, conversion rate. They're also the source of huge fractions of misinterpreted dashboards. Why? Because a ratio matrix can move when either side of the fraction changes. A drop in the ratio could mean the numerator fell, the denominator rule, or both. Always checks both before drawing conclusion. The example, applicants per job posting is decreasing. Same headline number, 3 different scenarios. Scenario A, numerator fails. Applicants are down. Job posting steady. Now you investigate the applicant side. Is unemployment falling? Did a competitor launch? Did the applications flow change? Scenario B, denominator rule. Applicant steady, job posting up. This is actually good news. It looks like decline on the dashboard, but it's a sign of platform growth. Scenario C, both move. Applicants down a bit, posting up a lot. This is the most common real-world case. Both signals matter, and you split the analysis into two parallel investigations. Okay, so we discussed a lot. So now let's bring everything together. Okay, so here are some key takeaways. There are 7 principles to carry forward. The first one, every matrix should ladder up to a goal. If no one good acts on a number, it's the wrong number. R does not star cover most product matrix questions, and you need to track leading indicator, not just lagging one. For ratio metrics, always check both sides of the fractions, and watch out for vanity metrics, Goodhart's law, and Rossi trip. Communicates and analysis as what happened, why it matters, next step. If you remember nothing else, just remember this. So product sense is the muscle, framework as the techniques, and metrics are the language. You build product sense by using products and asking, what should this team be measuring until it becomes the habit. I have some practice prompts for you here. So the first one, so pick any app on your phone, what the company likely not that metrics, what 2 or 3 supported metrics would you watch. The second one is like cost per user drop like 8% this quarter, list 4 hypotheses and segmentation you like to test. And third, a two-sided marketplace, see average revenue per buyer phone, but total revenue is up. So work through both sides of the ratio. And you can post your answer for these questions in the student launch session in the discussion board. And yeah, just practice on the real products you use and until it become the habit, and keep asking the correct questions. And remember where we started. So problem framing and risk score analysis told us what to solve and why it happened. And product metrics close the loop. So metrics tell us whether we solve it and what to watch so we can catch the next one early. So those 3 skills together frame the problem, find the cause, measure the outcome, are the analytical foundations that the rest of the course is built on. Okay, so thank you for listening to my lectures.